Okay, here's a problem from homework number 18. It says a genetic experiment involving peas yielded one sample of offspring consisting of 429 green peas and 134 yellow peas. Use a 0.01 significance level to test the claim, and here's the claim, that's the important part, the claim that 24% of offspring will be yellow. Okay, identify the null hypothesis, alternative hypothesis, test statistic, p-value. Okay, we'll be sure to talk about p-value, conclusion about the null, final conclusion that addresses the original claim. Okay, so if you recall from my previous video, the first step to solving claim, testing a claim, is to identify the null and the alternative hypothesis. So in this case, the claim is that 24% of offspring will be yellow, not more than or less than. So in this case, we now have a two-tailed test. Our claim is our null hypothesis is always an equality. So now the claim is going right here. The claim is here in the null hypothesis. It only happens when you have a two-tailed test. In this case, therefore, the alternative hypothesis would be that it is not equal to that exact 0.24. It is either greater than or less than that. So if we take a look here at our the back of your table packet, let's see, where did I put that? I believe it was here. Okay. Let's close these out. And right here, that was a left-tailed test. Here's a two-tailed test, right? So this is when our hypothesis is not equal to. Our null hypothesis is not equal to right here. So you can see now it's a two-tailed test, which means our critical space is going to get broken up into two tails. Okay, so how do we do that? Let's go back to our question. And okay, so now we'll get to that actually in step 3, which is when we defined the critical space and the critical value. But first we need to find p hat. Because our claim is regarding our yellow peas, how many peas were yellow in our sample? It looked like we picked 134 yellow peas. This time, though, they're not giving us the entire number of peas, but they are telling us that of those peas, 429 were green and the other 134 were yellow. So the total number of peas is actually this sum. So it's going to equal 134 yellow peas out of a total of 563 peas total. And if you do that on your calculator, you will get a 0.238. And I'm going to carry it out a little bit because we want to be as accurate as we can. Okay, so that's our p hat. All right, step 3 is to define on our graph the critical space and the critical value. Okay, so this case we want a 0.01 significance level. That is our critical space. But because we have a two-tailed test, that critical space gets broken up into two parts. We have half of it over here and half of it over here. Okay, so actually this space here is, that's 1%, would be half of a percent, so 0.0050. And over here is 0.0050. Okay, I'm going to let you guys go to your Z table and find that critical value. What is that Z score? You will discover that this is negative 2.575. Which means over here on the right side, Z is going to equal to 0.575. Okay, so we've identified our critical values, 2 of them here, and we've identified our critical spaces with this color. So step 4 tells us now to determine our test statistics. Okay, so this is just some number crunching. We have plugging into the formula our p hat, which is 0.238, minus our p, which is 0.24, divided by the square root of p, which is 0.24, times q, which is again 1 minus that p, so that's going to yield us a 0.76, divided by our n, which was the 563 total p's that were looked at. And if you go to your calculator and crunch those numbers, you should get a z-score for your test statistic of negative 0.11. Okay? So our next step is to go ahead and graph that on our normal distribution curve. I'm going to change colors here so we're really clear on this. I'm going to do my test statistic in blue. Okay, so here I am. Here's where p is 0.24 and negative 0.11 standard deviations below. We're negative, so we're below the mean, but we're not way out here at -2. We're just barely underneath the barely below the mean, which is right here. Okay, here is our z of our test statistic, which is equal to negative 0.11. All right. Okay. Before I go to drawing the conclusion about this, in this particular problem, we are asked to find the p-value. I didn't talk about that in my original lecture because you don't actually need the p-value to draw your conclusion. We can see already that our test statistic is not in the critical space. So therefore we know we must fail to reject the null. And I'm going to come back to that in a minute in terms of how we finish our sentence, because remember, now our claim was our null. So the fact that we can't reject it means we can't cross it out. So there's actually a possibility that our claim there's enough evidence to actually support that claim. But I'll get into the wording of that in a minute. In the meantime, we need to find that p-value. Okay, so our p-value, because this is a two-tailed test, our p-value actually is all of this space. Remember, the p-value is just the area under the curve that goes with that z-score, but it's also this side as well. Our p-value is also all this space. It gets broken into two parts as well. Okay, so if you go to your z-table, the probability that z is less than or equal to negative 0.11. If you go look that up on your z-table, you're finding this space here to the left of negative 0.11. You will see that that space is 0.4562. Okay? So this area under the curve is about 45% or 46%, 4562. That means that this space over here is also 0.4562. Okay, so our p-value is actually that 0.4562 times 2. Okay, so that actually works out to be 0.9124. All right. That is our p-value. And p-value is just the space under the curve that goes with your test statistic. It's one extra step that you sometimes have to take for your homework if it asks for that p-value. Okay, now because we're failing to reject the null, let's go back to our definitions on our two-tailed test. So we need to actually close some of this stuff out. And we're going to go up here to this two-tailed test, okay? And what you're going to see is because we're down here, our test statistic was not in our critical space. We failed to reject the null. Therefore, there's not enough evidence to reject the claim that. Okay, there's not enough evidence to reject the claim that. So it's really worded very similarly to the last problem. It just has different meaning now, right? So let's just go ahead and put this all back up. And okay, so because we're failing to reject the null, therefore, there is not enough evidence to support the claim. I'm not going to write this all, to support the claim that that 24% of the offspring will be that 24% of the offspring will be yellow. There's not enough evidence to reject that claim. There's not enough evidence to support the rejection of that claim. It's a lot of double negatives. So in simplest terms, it means because we can't reject the claim. Oh, sorry, this is actually not right. Not enough evidence to support the rejection of the claim. The rejection. That's where it gets a little different. Rejection of the claim. Where we can't reject this claim, we can't cross it out. So in other words, in simplest terms, there really actually is enough evidence. This is a very, very legitimate claim right here. There could be enough evidence to support it. Okay, but in terms of our problem, I want to make sure that you can answer the questions and confirm your work with StatCrunch. So what I'm going to do here is I'm going to open up a StatCrunch. We're just going to go through this with our, just to show you how to do it. So because sometimes when you do it by hand, the numbers are slightly off, and so I want you to be able to do it with StatCrunch as well to get those numbers correct and get the problem right on your homework. So we click to Stat, Proportion Stats, one sample with summary. And in this particular problem, our number of successes, the number of yellow peas we had was 134. The number of observations was 563. And this time we're doing a hypothesis test. Our null hypothesis was a probability of 0.24, and you'll notice that automatically comes up with the null, or the alternative. In this case, the default is not equal to, and that's exactly what we want. So let's go ahead and compute that. And you can see here just what we got, that right here, our z-stat is our test statistic. It's that z-score, it's negative 0.11, and our p-value is 0.912. So that's just what we got, confirming that with our technology. Right, so go ahead and try this problem in your homework. Good luck.